Good evening, everyone. Good evening, Dharya.
Good evening, sir.
So today's physics class, right? You want chapter 2 and 3. Aryan has exam and wants to revise chapter 2 and 3.
Sir,
Okay.
light and electricity.
Light and electricity. Okay, all right. So you are first doing with electricity. Okay, so we are continuing with electricity right now.
So chapter 2 brief, sir.
Chapter 2. So in chapter 2, what do you want to do then? I think there is everything
Sir,
that we have.
that colorful world, the human I am clear.
Human eye and colorful world.
That human I am done, sir. The colorful world only.
Okay, so in the colorful world, okay, I'll quickly revise that colorful world, right? So for you, I can do this. Just 1 minute. So in colorful world, in this part of the chapter, you have to learn about the three natural phenomena. What are those phenomena that you have to learn here? You have to learn about dispersion. You have to learn about scattering of light. So learn dispersion, scattering, atmospheric refraction, and a little bit in depth, you can say, for refraction. So you can add here a little bit about refraction. Another topic which you must be aware from all this is, which is applying in all of them, is here you have to be aware about the bending color of light. Yes. These things you have to aware about light, its color and frequency. So when we say color, we are mainly talking of wavelength or frequency. Both are the similar things which we are talking here. So these, if you are aware, just these phenomena which we have to study in this chapter for the colorful world. So first of all, we talk of this light, color and frequency. So we will be talking only about the visible spectrum. As we know that the visible spectrum is given as Vibgyor. So we write it as Vibgyor. There are other parts of light also, like here you have ultraviolet rays, X-rays, gamma rays, but they are not visible to us. Only this part, the Vibgyor, is visible to us. If you see, so they are arranged in the order of increasing wavelength. So how are these arranged? They are arranged in the order of increasing wavelength. So I hope everyone should be able to remember. They are arranged in the order of increasing wavelength or decreasing frequency. So which color is likely to have the maximum wavelength?
Red.
Red.
Red. Okay, red will have the maximum wavelength. That means lambda will be maximum for red. And if you talk of the frequency, so which color will have the maximum frequency?
Violet.
Violet will
Violet.
have the maximum frequency. Got it? So these two things you have to be aware. Then from the refraction part, you have to study that refraction is dependent on wavelength also. Refraction is not just what you have understood, that refraction we write n equals to c over v. Yeah, this is true, always true. But see, c is the speed of light in air, where v is the speed of light in medium. So the different colors, they travel with different speed in a medium. When they are in air, all of them they travel with the same speed. But when they are when they travel in some other medium, different colors have different speeds. Okay. So this phenomena is called as the refraction of light. So can we guess that? Can we say that all the colors will have the same refractive index for any material? Will it be true? Will it be true to say?
No, sir.
No.
No, sir.
Okay. So all the colors, they don't have the same refractive index, as they travel with different speeds in a medium. So they have different refractive indices. Okay. And we know that the refractive index is inversely proportional to wavelength. So we can write refractive index of a material is inversely proportional to wavelength. That means greater the refractive index, lesser will be its refractive index. It is inversely proportional to wavelength. That means if you talk with these colors, red will have the minimum refractive index and violet will have the maximum refractive index. Okay. So that is what we observe in case of a prism. In case of a prism, what do we observe? That red color deviates the minimum. The red color has a minimum refraction. That is why it appears at the top. And the violet color has maximum refraction. So it appears at the bottom. This is the result of this. Okay. And this phenomena we call as the dispersion of light. So what is dispersion of light?
Splitting of white light into constituent colors.
Yeah. So splitting of white light into constituent colors. The splitting of white light into constituent colors is called dispersion. So what is the phenomena that is responsible at the backdrop? That means the phenomena which is actually responsible for dispersion, that is the refraction of light. We observed the dispersion occurring through a glass prism. The dispersion occurring through glass prism is occurring mainly due to what phenomena? It is occurring mainly due to the refraction of light. The different colors, they have their different refractive indices. Got this?
Yes, sir.
Okay, so the different colors, they travel with different speeds. They have different refractive indexes. Alright. So different colors have different refractive indexes. They travel with different speeds. And that is why they bend by different angles. And hence they get separated out while passing through a glass prism. Why don't they separate while passing through a glass slab?
Sir, because it is not complex like prism.
Uh, what do you mean by complex?
Sir, like the structure.
No. Then you have to define complexity. What is complex then? Yeah, so what is complexity? Anyone? Can anyone? Subhansh, why does dispersion occur only through glass slab, only through glass prism, but not through a glass slab? Yes.
Sir, I'm not sure about that.
Okay. Anyone?
Can you repeat the question?
See, we observe that for a glass prism, there is refraction, there is dispersion occurring, but for a glass slab, the same phenomena doesn't occur. Why it is so?
Uh,
Yeah. So see, your glass prism is something like this.
Sir, is it something to do with angle of prism?
No. You see, a glass prism is triangular in it is a triangular prism like this. Whereas a glass slab is a rectangular slab. Like this. Okay. So for the glass prism, the opposite faces are not parallel to each other. For the glass slab, the opposite faces are not parallel to each other. For glass prism, the opposite faces they are not parallel to each other. But for a glass slab, the opposite faces are parallel to each other. So now you must be thinking what is the reason why should there be what effect will it bring about when it is parallel or not? Okay. So see, if you cut a glass slab into two halves diagonally, okay. So here, if you cut this diagonally, if I cut this glass slab diagonally, so this glass slab turns out to be two prisms. You can actually make two prisms out of a glass slab, or you can combine the two glass prisms to obtain a glass slab. So it works like this. If you have a glass slab here, sorry, another glass prism if I put here. So the first prism, it works as a dispersing medium, and the second prism, it works as a combining medium. You can see that if I combine both the figures, so what I can see is, yeah. So if I combine both the figures, then then the opposite faces will become parallel to each other. So here, if suppose you have a white light coming from this side of the glass slab, a glass plane, it's split into seven colors by the first page, and the seven colors they are recombined. So they travel like this to the second page, then they are recombined to obtain again a single white light beam from here, just like this. Okay. I'll also show you the faces of a prism. Just one. Uh, uh, so let's see how does a prism look like. Okay, see the image of a prism. See, this is how a triangular prism looks like. You can see it has two triangular faces and three rectangular faces. So when the light falls on the on the one of the rectangular face, well, it passes to the other face, it splits into seven colors. So this phenomena of light is called as the splitting of. So, or splitting of light, or we call it as the dispersion of light. If you observe the same thing happening through a glass slab, so through a glass slab, it's not possible. Okay. Why it's not possible? See, for a glass slab. Okay, see. Now this is a rectangular glass slab. If you cut this rectangular glass slab from between, do you think that we will be able to obtain a glass prism? Yes. How many glass prisms we will obtain?
Two.
Oh, sir.
Two. Okay, so we'll be able to obtain two glass prisms. So a rectangular glass slab can be supposed to be made up of two prisms joined together, so that one of the prism it works as a dispersing medium, whereas the second prism it works as a recombining medium. Okay, so since here the two faces are parallel to each other, that is why when the light ray enters through a glass slab, it does not disperse into seven colors. Got this? I'll also show you how the recombination works. So let's see the recombination. By slab. Sorry, not by slab. Yeah, see. Here you can see, if you cut a slab into two halves, you will obtain two prisms. So the first prism is making the light disperse into the seven colors, whereas the second prism, it is recombining it to form a white light. Got it? So see, understood this part?
Yes, sir.
So dispersion is basically the splitting of light into seven colors. So naturally, this phenomena is observed somewhere in the sky. Where do we observe this phenomena?
Scattering of blue light. Why is
Where?
sky is blue?
No, not the sky blue is not due to the phenomena of dispersion. It's not because of the
Rainbow,
splitting.
rainbow.
A rainbow is an example of due to the splitting of light or dispersion of light. So a natural phenomena which we see due to dispersion of light is the rainbow formation. Okay. But in the rainbow formation, this is not the only phenomena responsible. During the rainbow formation, there are some other phenomena also which are responsible for the rainbow formation. So if you see a rainbow, so a rainbow is formed. What all phenomena are responsible? So when the atmosphere has a number of water droplets present in the sky, when the sun's white light enter the water droplets, so these water droplets, they act as these water droplets, they act as small prisms, and the light from each of the droplet, it disperses into seven colors. So from here the light disperses into seven colors. Okay, so what all phenomena are responsible from here for the dispersion of light to occur? We observe here the phenomena of refraction. See, basically we studied that dispersion is possible because of refraction only. So refraction is a phenomena which is responsible here. You have refraction, dispersion. Refraction is occurring at both the ends. So you have refraction, dispersion of light, and also you have reflection of light also. So the light is getting reflected also. So there is reflection of light which occur from the other side. I hope you got it. See, when this light enters over here, at this surface you are having refraction as well as uh, dispersion. When the light is on this surface, then you observe reflection as well as here reflection is occurring from this side. So these are the three phenomena which are responsible for the rainbow formation: refraction, dispersion, and reflection. Now the last topic is scattering of light.
So, sir, during the rainbow formation,
Hmm.
when the white light passes in through the droplet, then like how can we write, sir? Would you once again say?
Okay. So when white light passes through the water droplets, okay, the water droplets disperse the white light into 7 colors, giving rise to the formation of rainbow. So in this way, you are short and you have explained everything.
Disperse light into?
7 colors.
Okay, sir.
So that whole soul is covered under. Then after that, you have the scattering of light. So scattering of light is a different phenomena. It's defined is different terms. So scattering of light, it is defined as the scattering of light. It is the phenomena of absorption phenomena of absorption of light by tiny particles and re-emission. So some of the books they also define scattering of light like this, as they state that it is the phenomena of it is the phenomena of scattering light caused when light falls on tiny particles atmosphere and is scattered in all directions, or it is redistributed in all directions, which we call as the scattering of light. Okay. So scattering is something like this: when you have these particles present in the atmosphere. Let's say these are the tiny particles of molecules which are present in the Earth's atmosphere. So you have the light of different wavelength falling over here. When the wavelength of the light is approximately the size of the particle, so these particles they absorb this energy and they re-radiate this energy. If the size of the wavelength will be bigger than the size of the particles, then no scattering will happen. So if you have the particle size to be greater than this, there will not be any scattering phenomenon. Okay. So if you have a light like this, it has a larger wavelength. So it won't undergo scattering. It will pass through it. With refraction, it will pass through it. There will not be any scattering. Got this? So which color will be scattered the most? This depends on their wavelength. The one with the greater wavelength will not be scattered, whereas the one with smaller wavelengths will be scattered. And as we know that violet has the smallest wavelength, so it's violet that is scattered, then you have indigo and blue. The minimum scattering that occurs is for a red color. The red color has the minimum scattering. Yeah, so understood this? On
Yes,
the
sir.
phenomena
Yes,
on
sir.
Yes, sir.
the phenomena of scattering, you have another thing, another question can be there like Tyndall effect. Okay. A Tyndall effect means the path of the light becomes visible when it falls on tiny particles. So the path of light becomes visible when it falls on tiny particles. Got it? That is Tyndall effect. The path of the light becomes visible when it falls on the tiny particles. So it is also this Tyndall effect, which is occurring due to scattering of light only. The particles, they absorb the light and they re-emit it. Hence, the path of the light becomes visible. So Tyndall effect is the path of the light becomes visible when light falls on it. Got it? Anything else? The last topic is, I think, atmospheric refraction, which explains the advanced sunrise, delay sunset, and twinkling of the stars. So I think twinkling of the stars, anyone can explain. Abhinav, can you explain the twinkling of stars? Why do stars twinkle? Yeah, Abhinav, why do stars twinkle? Okay. Is there anyone else who can explain why do stars twinkle?
Sir, because of ever-changing medium,
Ever
atmosphere
changing?
keeps on changing its density. So,
Yeah, because of the ever changing density of the Earth's atmosphere. So why don't the planets twinkle?
they are considered as extended sources of light. They are more nearer than stars.
So what is the difference between the extended source and the point source?
Sir, twinkling of stars is due to the ever changing.
Yeah,
Sir, twinkling of stars is due to the ever changing.
it is due to the ever changing density of the atmosphere. Since the density of the atmosphere is continuously changing, okay. So because of the changing density of the atmosphere, the light that reaches our eyes is not regular. Okay. The intensity of the light that reaches our eyes, it varies. Since the planets are very close to us as compared with the stars, so the light coming from them or the light coming from those stars is too large, and the small variations due to the refraction, they are not observable. Whereas the planet and the stars are very far off and the light coming from them has, has a small intensity. So whatever variations arise due to the atmospheric refraction, okay, because of the atmospheric refraction, you'll so because of the atmospheric refraction, the stars, they become twinkle. They appear to twinkle. As the light coming from them, it varies.
Okay, sir.
So just these are the topics which you have to study from this chapter. One more diagram, that is deviation through a glass prism, that you can do, or angle of deviation. The diagram for the angle of deviation from the glass prism, that is what we can do. Anyone has any other doubt from this chapter or from any other chapter?
No, sir.
No. Okay. Okay. All right. So from electricity, everything is clear.
Yes,
Okay.
sir.
Is there anyone whose exams are still to be done?
Sir, mine. I have,
Mine.
but sir, science is over. Science is completed yesterday.
Okay. Fine. Science is over. Okay. So I think everyone's exams will be over by Monday or Tuesday. So we can again focus on the chapter electricity. All right. Okay.
Sir, my,
Bye.
yeah, sir. Bye, sir.
Okay. Bye.
Yes, sir.
Bye, sir.
Thank you.
Thank you, sir.